Last episode, we walked a token from text all the way to a next word guess, but we waved our hands at the very first step. How does a token even become a vector? And there's a second mystery hiding in there. Attention, on its own, can't tell what order the words came in. This episode fixes both. A token becomes a vector by simple lookup. There's a huge table, one row for every token in the vocabulary, each row a learned vector. Token 4217 just grabs row 4217. That's the embedding. For Llama 3, that table is 128,000 rows wide and 4,000 deep, over 500 million parameters just to start the vectors off. Often the same table does double duty. At the very top of the model, the layer that turns vectors back into word scores reuses the embedding table. Flipped, it's called weight tying, and it's why vocabulary size matters twice. Once for memory, once for the final big matrix multiply. Now, the order problem. Here's the unsettling part. Plain attention is blind to order. Shuffle the words and it computes the exact same thing, because it only compares every token to every token. No sense of first, second, third. So we have to inject position on purpose. There are a few ways. Add a fixed sine wave pattern, learn a position table, add a distance bias, or the modern winner, RoPE. RoPE's idea is beautiful. Don't add a position number, rotate the vectors. Think of each pair of dimensions as a clock hand. The token's position decides how far each hand has spun. Fast hands track who's next to whom, slow hands track who's far away. And here's the payoff: when two tokens compare, only the difference in their spin matters. So, three words apart feels the same at the start of a sentence or the end. That's why RoPE generalizes to length it never saw in training. Let's draw it. Bottom half, the lookup. Top, the clock. Start with one token ID landing on its row in the table. Token ID picks a row. That row is the vector that enters the stream. And up at the top of the model, watch the same table get reused, transposed, as the layer that produces word scores. One matrix, two jobs. Now the order problem made concrete. Two identical word boxes, same vector, but one is at position 2 and one is at position 5. Plain attention can't tell them apart. We need to stamp position in. Here come the clocks. Each dimension pair is a hand. At position 2, the hands have spun a little. At position 5, they've spun more. Fast hands on the left for local order. Slow hands on the right for the long range. We spin the query and the key this way, and only those two, not the value. And the magic. Compare the token at position 5 with the one at position 2. The score only cares that they're 3 apart, the relative offset, not where they sit absolutely. That's the whole trick. One more thing on screen, crank the base frequency from 10,000 up to 500,000 and every hand slows down, so the same angular range now covers a far longer context. That's literally how Llama 3.1 reaches 128,000 tokens. Next episode, we finally open attention itself, the soft dictionary lookup at the heart of the whole machine. Blast note: B4 carries the teaser to NVIDIA 9. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.